Hi, welcome to the EECE 474 Team 4 instructional video. In this instructional video, we will go over what is infrared, what is the Pololu IR beacon transceiver, what are the pins configuration, what are the pins functionality, the Arduino coding, and finally a demonstration of the IR beacon. What is infrared? What is infrared? Infrared is a portion of the light spectrum above our visible range used by many modern remote controls to transmit signals, such as in this project, the robot and the beacon is transmitting signals between each other through an infrared emitter and receiver. Pololu IR beacon transceiver. The infrared transmitter and emitter that we're using is the Pololu IR beacon transceiver. As you can see, there are 4 directional IR emitter below the circuit board. By combining all 4 of these IR emitter and receiver to the circuit board, this makes the IR Pololu beacon transceiver. Pins configuration. As located on the screen, there are 4 IR transceivers corresponding to each of the direction. On the circuit board, there are 4 pins at the bottom labeled W, S, E, N for each of the direction. In addition, there are 3 other pins on the left side labeling the positive, negative, and enable terminal. Pins functionality. The 4 pins located in corresponding to the direction is active low, which means that when it has detected IR from the beacon, the analog data collected will be lower than 100 or a digital data of 0. In reverse, no detection of IR is equal to a 1 on the digital and over 900 for analog. Arduino coding. This is the beacon Arduino coding. In the beginning, I defined north, south, east, west according to the analog pins on the Arduino. Then I introduced the north, south, east, west as integers so that when I go to the scan beacon in the middle of the page, I can analog read the pins and set it as integers. And then in the void setup, I have to set the pin mode as input so that the beacon can be read. And finally, I have print beacon, which prints the analog reading onto the individual serial monitor. Advanced beacon detection, beacon array count. As you can see, this is the beacon array, where it takes 7 consecutive readings of direction to determine where the actual displacement of the beacon is. For example, if it was north, 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 east, 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 it shows that there are 4 readings of north and 3 readings of east, which determines that the beacon is actually displaced in the north direction. As you look back into the code, I introduced it as a robot direction as a function, and then I set direction with a 7 as a char array, so that in the direction array function, I can set it so that it reads 7 times in the middle. Now, if you go further on in the which direction function, it shows that every time it shows a north in the reading, it will add a count to the north, south, east, or west direction. So that is how we determine which direction the beacon is actually at. Beacon transceiver demonstration. As you can see, the IR that I'm holding detects the IR from the beacon. The red light indicates that it is detecting the IR. Beacon array demonstration. The robot beacon has been labeled with the individual directions. And here the serial monitor shows the beacon array count of the directions. Thank you for watching the beacon instructional video by EECE 474 Team 4 Nathaniel Young.